Alright guys, today I'm going to be starting on this little knife here, which I think would be called a boat knife maybe? If you know what a boat knife is, please let me know in the comments because I don't. I'm thinking maybe it's used for sailors, like sailboats, people who need to cut rope exclusively or something like that. But please let me know, but I'm going to be making one of these today, so follow along. Also, please let me know how you like the quality of this video. Look at the little gear in the bottom right hand side of your YouTube screen, and you should be able to see what resolution you want to watch this video in. If you have a 4K monitor, this video is going to be in 4K, and it's the first time I've done a 4K video, so I just wanted to know if you like it or not. So with all that being said, let's get into the build.
Alrighty, so we're going to be building this knife with some 1084 from Alpha Knife Supply. I've heard some really good things about their steel on the forum, so I wanted to give it a shot. This is 1.5 inches wide by 1/8 inch thick. So I'm going to be giving this steel a shot and see how it goes. Slight spoiler alert, it worked great. So the first step here is to cut it out on the bandsaw on the Bauer portaband here. After we get it nice and cut out, I'll go ahead and start profiling on the belt sander. So like I said in the beginning, I have no idea the history behind boat knives. I looked it up online, or at least I tried to, and I wasn't able to really find much about the term, or this design at least, the term boat knife or this design. So if you know anything about boat knives and where they came from and what they're for, or what they're explicitly designed for, go ahead and put that in the comment section below and teach me something there, please. So we are profiling this knife out on an old 60 grit belt. I like to not only get it profiled on the table there, but also to finish profiling along the spine, looking down the spine, so that I have all my scratches going in the same direction and I have that spine perpendicular to the flats of the blade. I next got this thing sprayed with some layout fluid, and then we start laying out our holes for drilling. We're going to be drilling number 13 holes there for our Corby fasteners, and then also a center hole for 1/8 inch decorative pin. After we have the center punched, we'll head on over to the mini mill to start drilling these holes. I'll also be drilling some weight reduction holes in this tang, not only to reduce the weight but also to allow a pathway for the epoxy to move around in there during the glue up and fill up all the void spaces in the center of this handle. So those holes I'm drilling with a number 12 bit. I have maybe 15 of these bits, and I don't use a number 12 bit for anything, so I'm using those as kind of my trash bits there. Next we'll lay out our center line here. This is going to be what we grind to for our edge. These two lines are about 20 thousandths apart. After I have the two center lines, I'll go ahead and use a square to mark off where I want my plunge lines to come to. So I mentioned in my last video that I'm doing more freehand grinding. I'm really enjoying it actually. I'm getting better as I go. I'll be using a 60 grit ceramic belt here. What you saw me do before was just knock down that corner with an older ceramic belt. I don't want to destroy the media on this brand new belt by just knocking down the corners. So this 60 grit VSM belt really hogs away some material here. It doesn't take me long at all to get the majority of my bevel work back towards the spine. I got this belt from Pop's Knife Supply along with one of my orders, and I'll definitely be ordering some more of these. So you see me, I'm working this one side here. I'm slowly putting pressure towards the spine of the knife to work that bevel all the way back. I'm about to show you a different angle where I will be switching to the other side to get that bevel work back as well. Notice that I'm using my thumb to apply the pressure there with my right hand, and I'm slightly pulling my left hand back as I get closer towards the tip. I've seen a lot of different methods online, and I think I'm going to try a push stick method soon and see how that works out for me. But so far so good with this method. I'm getting pretty darn close on my bevels here. My plunge lines, when I'm working with the ceramic belt, I'm trying not to make them, you know, dead nuts on each other. I just want them kind of close so that I can clean that up with the 120. So you can kind of see them there. They're not perfect. I then move on to a 120 grit J-Flex belt, and I'll be using this belt to work my bevels back towards the spine a little closer, and then also I overhang that belt on the side of my platen so that I can get a radiused plunge line. So this is a step where I try to get my plunge lines pretty darn close to each other so that I don't have as much to do post heat treating. It's worth mentioning that I get this blade around 90% done pre-heat treat. So I have about a 20 thousandths of an inch behind the edge there, finished edge, and then I also work back to just about the spine on my full flat grind there. Before heat treating, I'll also hollow out the tang to take a little bit more weight off. I'll be using some G10 handles here, and they're pretty heavy. I'll also file in my Spanish notch, or our sharpening notch, whatever you like to call it. You can't do this post heat treat because the blade's so hard, so I'll get my files out and I'll put this Spanish notch in there. I'm using a 5/32 of an inch chainsaw file to do this operation. So now our blade is to its finished pre-heat treat condition. We'll move on to drilling some holes in our handle material. I'll tell you why we do this in a second. But we're going to be using some about a 1/4 inch, a little bit more than a 1/4 of an inch thick G10 here from Alpha Knife Supply again. And this stuff's great. It's very flat coming from Alpha, and it works really good too. I mean, I've used G10 before, but I really like this stuff. Don't breathe it though. Make sure to wear a respirator whenever you're dealing with this stuff. So we get it cut out here. The next step is I get them clamped together with a cant twist clamp, and then we pass through those holes in our tang. The tang is now acting as a drill guide, and we drill out our number 13 holes there for our 2 Corby fasteners, and then our 1/8 of an inch hole in the center. So this mini mill, I use it for some milling operations, but it's really turned into a nice precise drill press for me. I probably 80% of the time I use it for drilling, and I do some flattening on scales and stuff. So what you see me doing here is trying to get an idea of the curvature of the front of my scales. I'll go ahead and draw this out by hand here, and then that's pretty much it for our handle scales. We'll come back to those later. So I'm getting out some Parks 50 here. I've switched exclusively to Parks 50 for my quenching. I am in an 81mm ammo can there. That's 5 gallons of Parks 50. And then we're going to get the forge cranked up here. So one of the benefits of the Parks 50 is that it allows me to have repeatable quenches. The oil doesn't degrade severely over time as, say, a canola oil will. The first blade you quench on canola oil is going to have different properties than the 50th blade you quench, whereas in Parks 50 that's just not the case. So I'll put some cards in the description above on how to heat treat 1084, but the first thing I'm going to do here is I'm going to normalize this blade twice. After I normalize the blade, I will bring it up to quenching temperature on the 3rd run and quench it into that Parks 50. So you can see me there checking it with a magnet to making sure it's non-magnetic. And then we'll go a little higher and quench into the Parks 50. It's a combination of using that magnet and having an eye. What you didn't see is I was actually testing it before then. It's become a habit just to keep testing it with the magnet. So now we have a super hard blade. It file tested easily. We're going to move on to our first tempering cycle at 213 degrees Celsius. I did pick up a small warp during the quench, and we're going to mess with that in our second tempering cycle so as we don't risk snapping this blade.
Alright, so we have the blade in the tempering oven along with 2 other blades that I'm working on. The tempering oven is ramping back up because it lost some temperature when I opened it. So we're about 5 hours out before the heat treat is completely done with the tempering being completed. So while we are tempering, we're going to be working on the handle scale. So this is kind of a pro tip, I guess some would say. the handle scales can be worked on while you're tempering if you go ahead and drill your holes before you heat treat. So not everyone does that, and I think it's a time saver if you have spare time in the day while you're tempering to keep working on your knife. So we're going to be able to profile out the handles. We're going to be able to angle the front of the handle scales, countersink the holes for the Corby fasteners, and then bring up the Corby fasteners, shorten those to the appropriate length for these handle scales and this stock. So we'll be able to do all that while we're tempering, so that's what we're going to do now.
Alright, so we're going to start off by rough profiling these handle scales in the bandsaw here, and then we're going to move over to the belt sander to get them profiled out. Where you really want to focus here is going to be on the front of the scales. We're not going to be able to come back and mess with the front of the scales after we glue the handles onto the knife. So I get everything pretty close here, leaving a little extra, so I have a little overhang after the glue up. I want to make sure to give myself a little room. And then we'll chamfer the front of the handle scales with a 45-degree wood block there. After we get these rough chamfered, I'll head on over to the hand sanding, get it clamped up, and hand sand the front of these scales to around 1,000 grit. Starting with a 320 grit paper, moving to a 600, and then finally to 1,000 grit. So this G10 polishes up really nice with 1,000 grit. I was pretty pleased with the way it turned out. I love all those contrasting lines there.
Okay, so we're going to do a brief lesson on Corby fasteners and how to measure and adjust their length to fit your project. So the first thing we're going to do is we're going to find the total width of your entire knife handle assembly. So step one is to find the width of your handle scales, which in our case is 0.54. And our blade is 1/8 of an inch. Okay, plus 0.54. So our total width is 0.665 inches. Next, we're going to be drilling a 3/16 of an inch hole in both sides of the scale. So if this is one scale, this is the other scale, and this is your 1/8 inch knife, we're going to be coming in 3/16 of an inch on both sides of your knife. So we'll take the total width minus 3/16 times 2. And that is going to equal the inside to inside distance here, which is the head-to-head distance of your Corby. So let's do that. So the total width is 0.665 inches minus 3/16 times 2. Okay. So that is equal to 0.29 inches, which is what we want from the inside to inside of the head here. So this is a stock Corby fastener from Pop's Knife Supply, and it is 0.35. And then this is a stock Corby fastener from True Grit, and it is 0.37. So you can see both of them are too big for our application, so we will have to take them down to 0.29. I also want to note that you want to be smaller than this number, otherwise you won't be able to tighten them any. So with a 0.29, I may go to 1/4 of an inch.
Alrighty, so here you see me putting those Corby fasteners in a drill and taking down their length. I normally start off with the female Corbys, and then I move on to the male Corbys to take them down. And then I'll start testing them like you see here in the drill so that we can get close to our final dimension. I got both of these down to around 0.27. This is a counter bore from Pop's Knife Supply. These things are the bomb. If you don't have one, you should probably buy one because it makes your life extremely easy when using Corby fasteners. So you can see I'm using the depth gauge in my mini mill, and we're going down about 3/16 of an inch into this 1/4 inch scale. And then this is what they look like after you get it drilled. I have a little bit of fuzz in there that I get out with a Q-tip, but that's it.
So the blade is still in a tempering oven, but I have an old blank here that we can use as a demonstration to see how our Corby math worked out. The last thing I did was countersink these holes in the handle scales, 3/16 of an inch deep, and then these Corby fasteners have been shortened to around 0.26 to 0.27 inches from inside to inside head. So before I glue up all the time, every time before I glue up, I'll test fit these Corbys so that you're not in the middle of a glue up panicking because your Corbys are either too long or too short. If they're too long, you won't be able to tighten down the scales, and that's kind of the whole point of why you're using Corbys anyway, because you want to be able to have a mechanically squeezed handle scale. So anyway, let's do a dry fit here. I'll put one Corby in one side, I'll put the other male Corby in the other side, go ahead and lay the knife in, and then take a screwdriver and start tightening here. Alright, so it looks like it's tightening down just fine. I'll go ahead and make sure they tighten and don't just spin. Yep. Alright, so this is the Corby is the appropriate length. I'll also test the other Corby, but that's what I normally do before I glue up, and that is how you install and do the math on Corby fasteners.
Okie dokie, so tempering cycle number 1 has been completed. We'll bring it down to room temperature in my nasty slop bucket here. Then we're going to address the warp. So we have a warp in this blade. To address this warp, we are going to counter bend it against the warp during the second tempering cycle. I've seen this work a couple times. It definitely helps, every time. So make sure you're doing this in the second tempering cycle though, because the last thing you want to do is try clamping up your blade and breaking it before your first tempering cycle. The blade is really hard after the quench. But anyway, we take some C-clamps here and we get it clamped up, bending in the opposite direction of the warp. I may have it with a total deflection from the center line of about 1/8 of an inch counter bend, and that seemed to work very well. Another slight spoiler alert here, this thing came out great. So anyway, I get it clamped up, and then we move on to the second tempering cycle at 213 degrees Celsius to make sure we get this blade in a tough, usable condition. As a side note, I'll put some cards above if you want to build a PID controller for your tempering oven. This thing is extremely handy. It's really nice to know I'm getting precise tempering temperatures.
That's a miracle. Alright, so this is day 2. The blade is surprisingly straight after that tempering operation. The goal today is to get this blade ground up to its final grit, which is going to be around 400 grit on the belt. Then stonewash it, etch it, then stonewash it, and then put the handles on and get it glued up. So that's the goal for today. We're starting a little late, so we'll see if we can get it all done, and let's get going.
Alright, like I said, this is day 2 here. Out of the tempering oven, I take it to a semi-worn 120 grit belt just to get some of the crud off of this knife, anything that's left behind from the heat treating process. So I'll take down the flats and the spine, and I'll hit the bevels a little bit with it, but I'm going to be moving on to a Hermes 120 grit J-Flex belt. I got this also from Pops. I like buying a new belt or two every time I make an order just to try something new, and this is my new belt. So it worked pretty darn good. I normally use the green made in Germany belts from True Grit, the J-Flex belts, and those are great, but I really like this one too. I think I got about 3, maybe 4 blades out of this belt before I felt like it started losing performance. So that's the finish it leaves. You can see I got it really close to the spine there. I left just a little bit of meat there to get with my 200 grit belt here. So I moved on to that True Grit, made in Germany, cheap J-Flex belt to get me up to a 220 grit finish. After that, I move on to a 400 grit belt to the same manufacturer and get up to a 400 grit finish. You can see it's nice and fine there. And then I move to the Scotch-Brite belt after this one to kind of make that finish nice and milky. I'm using a medium blue Scotch-Brite belt. I really like the finish this thing leaves, especially if you're going to be stonewashing. It's a good pre-stonewash finish. You know, I know there's a way to clean these belts. If any of you guys know how to do that, please leave a comment in the comment section. I would really like to clean this belt. I know they're pretty expensive, and I want to get the maximum use out of this belt. But it has a lot of miles on it. So that's the finish I achieved. We're next going to stencil on my maker's mark. I'm using a DIY etching machine there that I built. This thing works great. I'm going to be doing a DC etch since I'll be stonewashing this blade. There's no need for the AC etch. The AC kind of gives you darkness, and the DC gives you depth. So we're going to go ahead and switch this etching machine to DC, and we're going to put a nice deep etch into this blade. To do that, I normally hit it for about 12 times with 1 second holds, and that gives me a nice deep etch. It will catch your fingernail. It's almost like somebody stamped your blade, which is what I'm going for. If I was going to be doing a hand sanded finish on this one, I would also hit it with AC after the DC etch to make it nice and dark in the valley there. So after we get this thing etched DC, we'll take off the stencil, spray it all down with a little bit of Windex, and then hit it on the Scotch-Brite belt again to go ahead and clean up that etch. Now that the etch is cleaned up, we'll throw it in to the acid here for about 10 minutes. Go ahead and get it nice and etched. Then we'll clean it up with some steel wool, and then I will normally put some baking soda on the blade to make sure that acid is neutralized. We'll then put it into my homemade tumbler here that flexes the belt sander. I also have a video on this if you're interested, but this is a kind of a nice little time saver here. I run this guy for about 12 minutes, and it allows me to get around the shop and start cleaning up the previous things that I did and set up some stations for the next operation. So it's a nice little time saver there. It's not a lot of time, but it definitely adds up, especially if you're doing a batch of knives. So to protect the blade during the glue up, go ahead and wrap it up with some paper towels and some tape here. Last thing I want to do is get glue all over my blade and have to clean it off. It just makes it easy just to pull that little sheath off of the blade once you're done with the glue up. Then take some Prep All, I think is the name of this stuff. It's basically kind of like an acetone, and I make sure that the tang is nice and clean. All the other components I generally make sure they're clean with a little bit of rubbing alcohol. You want to get all the oils off of your components so that the glue sticks efficiently. So I'm mixing up some G-Flex epoxy from West Systems. This stuff is excellent. I did a head-to-head comparison between this and BSI, and I think this stuff definitely performed a little better. Don't get me wrong, the BSI epoxy is perfectly adequate for making knives, but I really like this G-Flex epoxy. It's super tough. So we go ahead and we put some G-Flex on the first scale, both in the countersunk holes and also on the flats. Push in our two female Corby fasteners, and then we put some glue on the tang itself, and then we repeat the operation on the first scale on the second scale with the male Corby fasteners, get everything lined up, get the Corby started, and then hammer in that center pin. I like hammering in that center pin before tightening the Corbies, just so that as the glue compresses, it squeezes into all the crevices on the inside there. After we get the Corby fasteners snugged up, not too tight, just snug, we go ahead and clamp the blade in the upright position so that I can clean off the squeeze out on the blade itself. I don't want to leave any of this glue on the front of the handle scales or on the knife in that ricasso area, because that's going to be hard to clean up later. I then take the remaining glue, and keep it somewhere so that tomorrow, when I can start working this blade, I can verify that glue has had time to harden. But 24 hours later, we take this wax paper off and we get to shaping the handle. My first step is to cut off the heads of the Corby fasteners, the bulk of the material there. These are brass, so it's pretty easy to do on this bandsaw. And then we're going to go ahead and start hitting it with the belt sander. So step one of my handles is I like to get the flats flat with the pins and the Corby fasteners. After I get the flats flat, we'll move on to the spine of the knife and bring down the handle material to the spine. I'm sorry, to the spine on the tang, or I guess on the tang of the knife. You know, this can take a little bit of time here. The G10 worked pretty good though. I will say it came off pretty fast. You want to be a little careful. I normally start off with a 60 grit belt. I don't like getting it all the way flush with the 60 grit belt because you have to get those 60 grit scratches off the metal of your tang. So I normally get it really close, and then I move to either a 120 or a 220 grit belt to take it all the way flush. After we get the handle scales flush to the tang, we'll move on to doing a little shaping here with the 60 grit belt. You can see that I'm rocking the blade back and forth. This is giving me a little bit of curvature on the outside of the scales. You can see here that I have that curvature, but the top and the bottoms are still flat. So after we get that initial shaping done, I'll move on to a J-Flex 1-inch scalloped belt. I think it's Klingspor that makes these belts. I also get them from both. Actually, I get these belts from both True Grit and from Pop's Knife Supply. So that's the finish with a 200 grit J-Flex scalloped 1-inch belt. I then move on to some hand sanding here. I start off with some 320 grit Rhino Wet sandpaper. You can see me using a sanding bar there. I use a sanding bar to get the spine nice and smooth and all the scratches going in the same direction. After you use that scalloped J-Flex belt, you'll have some horizontal scratches in your tang metal there. So I use that sanding block to get that nice and flat, and then I bring the whole blade up to a 1000 grit finish. And then that last step you saw me do there, I was taking the Scotch-Brite belt and I was just hitting the spine of the knife and then all along the tang to make sure that the whole tang, all the scratches are going the same direction, and it's a nice satin finish. Then we get it clamped up in our sharpening jig here, and we move over to our Win water-cooled sharpening system. I did a review on this sharpener recently, so you can go ahead and find that. I'll put it in the cards. But I really like this thing. It works pretty good after you get a couple of the kinks worked out with your technique and your tools. So what you can see me doing here is I'm bringing that stone up to a nice clean 220 grit on the rough side of that dressing stone, and then I end up moving to 1000 grit later on the smooth side. That right there is the Tormek angle finder. That thing is a godsend. It's way better than the one that comes from Win, and it will allow you to target some really nice secondary bevels. I'm targeting on this knife around a 19 degree secondary bevel, and I have about 10 to 15 thousandths behind the edge. So like I said, I really like this sharpening system. It goes from a 0 edge to an edge maybe in about 15 to 20 minutes, and then I come over here to the leather wheel and strop it. And this knife came out super sharp, and it, you know, like I said, pretty fast too. So it's nice being able to get nice repeatable results with a sharpening system that's pretty easy to use. And then one of the last things I do here is I take a little bit of Mother's car wax and I wax this entire blade from tip to stern there, just to make sure that this blade is nice and protected going forward. I got that tip from Horserite. He's on Instagram. I'll put a picture of his Instagram handle here. He's a wealth of information. His name's Dave, and super awesome knife maker. He makes great knives, and he's also a wealth of useful information too. So I really like how this knife turned out. You know, this boat knife turned out. I hope for those out there who use boat knives that I did it justice. But I really like the G10 on this one too, so I'll definitely be buying some more from Alpha Knife Supply. So that sums up this build here. If you like this video, go ahead and hit the like button below. Also make sure to hit that subscribe button along with the bell notification so that you will be notified whenever I post new videos going forward. Until then, I'll catch all y'all on the flip side.